Anton is also another co-founder of 1inch, and he's going to talk about the technical architecture that's powering this new cross-chain world. So to give you an overview of all the things that you need to know about and how things work under the hood, please welcome Anton. Welcome, Anton.
Hi, Kartik. Thank you. Okay. Hi, everyone. I'm here to reveal like a high-level architecture of cross-chain stuff in 1inch. So yeah, actually we use 3 different layers. The bottom layer, we call it intense layer. Right now it's 1inch limit order protocol. This layer is able to use user funds by their digital signatures. Next layer is built on top of bottom layer is the price discovery layer. It's what we call 1inch fusion. It's basically adds Dutch options. And then there is one more layer on top. We call it 1inch fusion plus, but that's actually atomic swaps layer. We have escrows there implemented. So yeah, we will start from limit order protocol. So that's not usual diagram. That's diagram of value flows. You could see how different assets are being transferred, like rights for those assets are being transferred among entities on this slide. And here you can see also transaction that resolver, or how we call taker, they can do transactions to fill orders, while signers or makers, how we call them in this protocol, they only release order with digital signature. We call it signed order here. So yeah, those who want to create orders, they create them off chain, and those who gonna fill them, bring them on chain. And yeah, that's how it works. Moreover, limit order protocol have some features which developers could use to achieve something outstanding. For example, it have predicates. So there is basically predicate is a static call which check arbitrary things, and it can return true or false, meaning it would let order to be filled or not. So for example, if you would just integrate Oracle there, you could make Oracle which works like a stop loss, for example. It could check price on some Oracle, and then you will be able to sell only if price will go down. You can't place order right now because it will be filled immediately. But yeah, that's like one of the examples what could be built using predicates. There are also interactions. So basically, limit order protocol handles 2 transfer froms. Transfer from maker to taker, some funds, and then some other funds from taker to maker. And this protocol is also notifying you if you need to do some pre-interaction, mid-interaction, and post-interaction. Those are interactions between those 2 transfer froms. And one more cool thing is dynamic prices. This is actually a thing which lets you write arbitrary smart contract with arbitrary logic for forming a price. This means that limit order is not only working with fixed prices, it also works with dynamic prices. And this means that you could build, like incorporate arbitrary logic there. This could be different auctions, exponential auctions, oracles, stop loss orders, like you could come up to anything here. And yeah, actually limit order protocol have huge variety of flags. Using some of them, you could achieve like interesting things for you. Like for example, if you want this order to be as cheap as possible, you could enable one of 2 options. It could you could allow only single fill orders, or you could allow only like full filled orders. If one of these options is enabled, this means that you will be spending 15K less gas on invalidation. It's using like bit invalidation in this case, for example. And there are many other options. I recommend you to check it out. That's how it's worked for Fusion. Actually, Fusion is is Dutch options on top of limit order. So you could see orders each have its own auction, and resolvers are participating in these auctions. Since this is Dutch auctions, how they work, they participate passively. So they just wait while price is being improved over time, and they compete with each other. That's why when exchange rate is affordable for them, already like a little bit profitable, they can't wait more because someone else can steal this order. So yeah, that's how they compete. And we think that that's actually one of the greatest mechanisms for price discovery. Yeah, that's how usually one of the auctions look like. This is example from on-chain. This was a almost 13 million swap from USDT to wrapped ETH. And here you can see chart how price was going on this auction. And you can see multiple fills happened in like less than 1 minute. And this gave 200,000 surplus comparing to market price if you would try to exchange it with market order. So yeah, that's like one of the examples, and also visualization. What is Dutch auction? This is a thing where price is moving from good price for signer maker to worse price, but it's getting improved over time for takers, resolvers. Yeah, what is Fusion Plus? Fusion Plus is built on top of 1inch Fusion. So basically, it's like next layer. We have limit order protocol. We have 1inch Fusion with Dutch auctions set up for price discovery. And we have this extra layer, which is like atomic swaps, escrows, HTLC, escrows, all these things. HTLC means hash time locked contracts. So I have an interesting scheme how it works. I tried to make it easy to understand, so I hope you will be able to easily understand it. So what's happening here? Some arrows have numbers. That's basically numbers of transactions or like interactions. Other arrows, they are showing how funds are being transferred among different entities, how rights to those funds are being transferred. So here we can see that user originally creates two things. It creates signed order, including hash of the secret key. And they also create this secret key, which they do not reveal until something would happen in the future. And then when resolver is happy with the Dutch auction price happening with this order, they are bringing this order to limit order protocol on source chain. You can see it's arrow number 1. And then funds are being locked inside the source escrow, which is locked by timer and by secret key. Then call number 2 happens. Resolver interacting with limit order protocol on destination chain, and it's locking destination funds, destination assets on destination escrow. And then resolver is waiting for user to reveal the secret key. So you could see it's arrow number 3 here. So when user is happy about destination escrow parameters and finality, most of these things on EVM are being checked by one hash computation, because those escrow, they're basically create 2 proxies, which are deriving their addresses from salt, which is hash of all the possible parameters of this atomic swap exchange. And yeah, what's happening next? When user is happy about finality and parameters of destination chain escrow, they are still owning their funds via non-revealing this secret. So once they decide to reveal it, it would unlock both of the escrows on both chains because they are locked with the same secret. If user would decide not to reveal the secret for some reason, then destination escrow can be canceled first. Its timer is faster, and resolver funds are safe. So yeah, that's how it looks like, and that's what I try to show. But the thing is that all those source blockchain and destination blockchain, you could see like limit order protocol, like escrow there. Yeah, that's how it looks for some chains, or maybe most of the chains. But some chains like Bitcoin, for example, they do not have any like smart contract functionality. Their nature is a bit different. They built with the UTXO, where outputs are programs themselves which you have to satisfy to be able to spend. So yeah, the architecture of underlying blockchains could vary, but the thing is that they are actually, I think almost every chain is capable to have this HTLC functionality for atomic swaps. Since this idea of atomic swaps, it's initially appeared on Bitcoin Talk forum in 2013. It's like 12 years ago. There were only Bitcoin-like chains at this moment, and yeah, I think if something is possible to build on Bitcoin, you probably will be able to run it on any possible chain. Yeah, I'm even not talking about smart contract chains. Yeah. So yeah, we believe that actually atomic swap scheme is the only scheme which is self-custody for the users. And that's like architectural step to make this thing like we want this thing to succeed and be there like forever. If something is built on technologies on architecture level with these things inside, like atomic swaps for self-custody, yeah, it should work finally. So yeah, if because working on custody solutions is something I still think it's like not very long-term vision, because yeah, there are like too many risks here. I mean, the more things we would have built permissionless, the better future would be, because we always can build like custody things. It's easy. So yeah, let me check through my presentation. Maybe there's something more to add here, or we can switch to questions. Oh, I think that's it.
Anton, thank you so much for that. I think the part that is interesting right now is that the questions are actually being taken over and hijacked by Sergey on the live stream, because he's now just talking to the hackers, and they're going back and forth on a couple of these. But maybe I'll give a couple minutes to anybody on the live stream to ask any questions to Anton, especially on the architecture. The one obvious question we got is that there's so much incredible technical detail there. If we can get a link to your slides, we can share that with the attendees. That's like the first question we got asked. So, Pomik, I'll ask that question.
Sure.
I'll get you the link, and then I'll get that posted in the live stream chat.
Yeah, for now, I sent it to you,
Okay.
but yeah, we
Yes,
need to make it as a link. Yeah.
we will get that slide up. The other piece, I guess my question to you is, as you kind of looked into this, and obviously Bitcoin is like a perfect example for this, because you kind of have most parts of what you would like in a smart contract there, but with some limitations. What have you found like is kind of working and not working when you talk to people building on top of Bitcoin, and and they want to integrate DeFi from EVM? Like, what are their wishes? What are their complaints? Like, how do you think that's going to change?
Oh yeah. So yeah, actually functionality for computations, for variety of computations is very limited on Bitcoin chains and Bitcoin-like chains. But I think some of Bitcoin-like chains have more opcodes which are working. Actually, in Bitcoin, a lot of opcodes are disabled for security reasons, even if we do not understand those reasons. It's actually not very easy to find the reasoning behind some decisions in Bitcoin protocol. And yeah, the thing is that what I saw from the market, what people tried to build, this is like a different layer two approaches for Bitcoin and other things. But there's a huge difference between layer two built for EVM like chains and for Bitcoin like chains, because on EVM, layer two chains are being governed by layer one chain, actually by smart contract being deployed to layer one chain. So every layer two have a special smart contract deployed to layer one, and this contract is actually guaranteeing the safety of this layer 2. This guarantees that block producer of layer 2 will not steal everyone's money, and all computations should be correct and signatures should be correct. But that's what's not possible on Bitcoin. So how layer 2s on Bitcoin work, they actually use Bitcoin for data availability and for ordering, sequencing of the transactions. So people just put EVM-like transactions into Bitcoin as a plain data, and this data is just being stored and ordered in the right way. So on other side, they just extract all transactions they can find in this blockchain. They put it in their own chain as a separate blockchain, and they can run it. So they're using Bitcoin as data availability here. And yeah, I'm not sure this is something what can be called layer 1, because whatever logic is happening in their chain is not being covered by Bitcoin in any way. Yeah, I'm afraid that Bitcoin network with allowed opcodes is only being able to work for like few specific use cases, like multi-sigs. Okay, they built a Lightning Network, it's payment channels, thing. Yeah, we could have payment channels, we could have like atomic swaps. Yeah, I mean, but I would not expect variety of applications for Bitcoin, like tens of different apps.
Yeah.
No way.
If the only tool you have is HTLC, then you're kind of limited to everything you just said, because that's kind of the max you can do.
Yeah.
So maybe my last question here, and we can sort of get back to the rest of the hackathon for the hackers is, are you looking forward to people building some specific projects? Is there something on your wish list that people should hack on? And I say that with like a warning to everybody who's going to hear the answer. Is going to be a super technical thing Anton's going to say. So you could say the challenge.
Actually, when I originally saw the list of different blockchains, of different blockchain ecosystems, which have like different nature. I mean, you have to learn different skills to develop software for those different platforms, because they have like absolutely different programming languages, virtual machines.
Yeah.
I was actually amazed by the number of the projects, because I usually work within EVM ecosystem, and I'm like slightly touching some other ecosystems. But yeah, I was amazed. It's like 15 to 20 different blockchains. That's huge. And I don't know who can cover this. Only hackers on Hackathon can cover this. No any way for like any single company or a few companies to build this. Yeah, I think we need cumulative efforts of all the hackers.
Amazing. Well, Anton, thank you so much for that amazing presentation. We shared the slides already with the hackers, and I guess we'll see you in 2 weeks when you get to look at all the amazing submissions that come out of this.
Yeah, thank you, Kartik.